Hello everyone, this is another ABAQUS tutorial. In this tutorial, I want to model and simulate an RC reinforcement concrete column. And then after that, I want to evaluate the compressive load bearing capacity of this column. So this column has a 2 meter or 2000 millimeter length or height, and the cross section is 300 by 300. So for simplicity, we use 4 rebar, which is diameter 20, and we will distribute about 20 straps across this column. So that this is 150, so then it will change to 100. So the first part is we will model and apply a compressive test to get the capacity of the load column. And the second part is we will then again we will use that capacity load to see the performance of the structure. Mostly we use two kind of analysis. The first analysis I want to conduct standard static, and the second I want to use explicit, and then I will add some sort of shear failure on a concrete to see how the column behave. So we go to here and create a concrete. The concrete column is column you can say 30 by 30, which is using solid element, and I can select a rectangle and give minus 150 and minus 150 for the X and the Y direction. So now again 150 positive and 150 positive. So the column is the concrete section is created, and just let me give the depth or height 2 meter. And the second is the strap area. I can call straps. The straps is a wire using planer and giving, so the cover is, or clear cover is 20 millimeter, so which reducing 21 side, 21 side, 20 top, 20 bottom. So for this now I can give 130 minus 130 and minus 130, so as a square shape. Now again, and position 100, position 130. The strap is also constructed, and the second is called longitudinal rebars or rebar. So this is also wire, and I want to give a 2 meter or 2000 millimeter. And now this also completed, and the second part is defining material. In the material we have steel and we have concrete. I'm going to add the material from my library. So the steel is this steel, and the concrete is concrete CDP 25. Now we can see in first steel, the steel elastic is this one using millimeter, megapascal, Newton, and the plastic is this parameter. And the concrete CDP is using this material, and the compressive strength is maximum 25 megapascal. So I will put this the link of this model. You can get and just do as a tutorial and get the result, and then you can play with some parameter to see how they behave. Now here, the first I want to call a column or concrete. We need to create a concrete section for the concrete column. The second is I should define. The second, I want to create a profile for the longitudinal rebar and transfer rebars. and I can call it longitudinal rebar. So the longitudinal rebar is a circle and it has 20 millimeter diameter, so that the radius will be 10. And the second is we go again, and this time called straps. Uh, and so it's 6 millimeter diameter, so it costs 3 millimeter radius. Now we create it, and now again we should define section for them. Rebars, and the section is using a beam element, and longitudinal, the steel material is this one. And again I have to create one for straps, the same method, but this time using straps. And okay, so now we created, we should apply, or we should assign them to the element. Now we go to this longitudinal rebar and the straps. So finished. One more thing is defining a orientation is necessary for the beam elements. Okay, and the rebar, doesn't matter which direction you can give because it's a circle, so any direction is equal. And then next step, we go to the assembly and import all the elements to make assembly. The first is concrete and apply, and the second going to straps in this location. Okay, and the last one is uh, this one, longitudinal rebar. So I'm going to rotate this one, using this angle, and I want to take it this point to this point. And the next, I want to populate that. So first select this one, I want to remove, and select this one, populate other two corner, 260, and this is also 260. Now I want to make a little move of this rebar to sometimes during the interaction it will not embed with the concrete. So taking 0.0, and in the Z direction I want to take it 10 millimeter. Now it's okay. Now I want to go to the select this one. I want to give 100. So this direction and front, and I'm going to populate it to end of the structure. Okay, and the last one is a little front. I'm going to select 0, 0, and the second point is going to 0, 0, minus 20. So it's correct now. So we finished, and select all and rotate, make it in a YX plan. And one more thing is to bring it to origin, and this point to 0, 0. And now it's fixed, and we're going to define a step. So this is okay, and go to step. In this part, just I want to consider a standard solver or static analysis, and the second part, which is the evaluation of the so first we will get the capacity curve, and then applying the loads in the next step, and in the next step we can consider some shear failure. So this is now going to define a static, and selecting general static, and selecting activating some dissipation energy fraction between the concrete and rebar, and time period is let's suppose 10 seconds, and I'm going to a very large number, so during the analysis there is no lack of increment. So going to 0.0105, a small one, and 1 e minus 15, so very minimum increment, and this is 0.1. So we want to slowly apply the displacement in the top of the structure, and then see the structural response, or draw the curve of the force displacement. This is okay, and we can, before that I'm going to draw some point, center point. I'm going to take one here. This is one center point of the column, also one center point here. In case the concrete is not eccentricity, then you can apply the eccentricity percentage, shifting this by some little difference. Let's suppose you have this option, you can take this point and define a little other side, so the loading will be unconcentrated, concentrated. So the concentrated load is changed to unconcentrated load, so that you will give difference response curve. So now it's concentratedly loading step, which is seems that structure is located in the column is located in the center of the building. In case you have in the edges on the corner, so that you have to consider that eccentricity, and that eccentricity can be a topic for discussion and for analysis of such kind of column. Now I want to create a reference point in that area. So one reference point for boundary condition, one reference point for loading, and I want to create a load called loading point, and that already reference point 1 is the loading point. And what I want to do is just first of all, let me go to define some other parameters, such as the concrete damage and also scalar degradation. Scalar stiffness degradation, this one. And also we can go to the state field variable and using this command, and the output is every n increment is 1. So okay, now here I want to get just using that set loading, and I want to get the vertical load and also vertical displacement of that point. Going to U2 and REF2. So first we will apply the displacement. Actually we usually use a sort of device, then loader support, then pushing them down, and then there is some reaction force. So that reaction force in the finite element is equal from the bottom to here. So and the next step, instead of that pushing displacement, we will use the load which we got from this analysis, and then we will see the response of the structure. Now interaction. In interaction, just we have two interaction. We can use coupling or tie. So that means we want to tie this node to the entire surface, or coupling. So both are okay. Let's make it coupling. So the coupling one is this point. I can select that geometry here and then go to node region or displacement. So here is, and I can see So that also represents the load will distribute equally to entire elements, entire surface. Now again I can go to second here. This time I want to take this point as control point and node region here, which I created both. And the last interaction is embed. The embedded region, which is interaction between concrete and rebar. I'm going to pause and I can going to column, so remove it, and I can select all this still, and I can go to all models. And now here is, and I can show everything is done. Now injection is finished. We go to the loading. So we both use an initial first called fixed base. Fixed base, and I'm going to select this point as a fixed encaster, and the second is the top called displacement. And this is in a static, so I'm going to select displacement and selecting that point which already defined here. Now I want to restrain all other direction except in a y direction, so that maximum is going to push this to 1 centimeter. So during 1 centimeter, so concrete is a brittle material, and it will start to crack and crash. Or I can give 20 milli to see more deformation. That should be in a negative direction. SPM minus 20 to get down. Now the loading is finished, so the last thing is meshing. We go to part, and here is meshing, giving 100, and stirrups, and let's give 25, and concrete, and the concrete is going to 100. So this is very small coarse mesh, and I want to make this one to 50. It's a little bit fine mesh. Now it's better, so we can go to the finished, go to the job, and this time we can create model 1. It's called model 1, and submit it. It's called the following posts have been element without any section. So the concrete is forget to mesh, assign the section. So here is the section, concrete. Another is okay. One more thing I want to show you in the assembly, that going to here, going to rebar and display option, and I want to see this is the reinforcement rendering. So go to job, and now I want to submit again. Job is submitted, and I want to consider the monitoring to see if there is any error to fix. And now it's starting 0.7, and it's quite good, and almost reached to 1 second. So I need to finish 10 seconds, so then we can see the result. Now the analysis completed, and it took about 107 increment steps. So I'm going to call result, This is the result, and this is first one mesh stress which has reached to a yield point, and I'm going to here and just go to part concrete column, so replace, and this is the concrete column stress, but it didn't reach to the compressive yield because concrete compressive strength is very high. It can resist a very large compressive load. If I go to the concrete tension damage, so this partially this area, and some other area is damaged. Also in the compressive damage also occurred in bottom and top. Now I want to see the response curve. Going to the ODP output, and we're giving these two curve, and here is the curve, and here is the curve, and I want to create a FDP curve. Now here is combine, and times -1 because it's in a negative direction, and for both -1 times the reaction force. We're going to save it to FD, force displacement curve. So I'm going to plot, and here is, so this is the concrete behavior, and we can go to see the maximum displacement. So this is Newton. When we divide it by 3, and it will become 2500 kilonewton. So the concrete compressive strength is very high, and this is the deformation. So after 5 millimeter deformation, so it start to crack or damage this area. So what's next? So in the next tutorial, I want to get this data, use this data, and this is the data, and I'm going to export it. So the maximum, okay, I can go to copy to Excel sheet, and paste it to Excel sheet, and I can again click here, insert a graph force. So here is the compressive strength. Now I want to see the maximum of this point is here. This is the total capacity of or ultimate bearing. So it is about 4.9 and 2003 kilonewton, 2802 kilonewtons. So 4.95 millimeter. I can call it U or DA ultimate, and FE ultimate is 2 this point 2802779. Now this is Newton, and I can put Newton, and this is millimeter. So this is that this total equivalent displacement with ultimate force. Now in the next tutorial, I want to use this load to see the structural response, but in a dynamic manner. Okay, keep tuned and stay with us for the next tutorial. See you next time.